We are going to discuss SCTP, which is one of the important protocol we have in transport layer. Okay. Earlier, if you remember, we have considered UDP and TCP, right? Now we are considering SCTP. Before considering SCTP, we need to address something like why exactly we are going with SCTP. Okay, what is the problem we have when I consider TCP and UDP? Then we will be going with SCTP. Okay, so the first thing is SCTP stands for Stream Control Transmission Protocol. So stream control transmission protocol. This is reliable, message oriented transport layer protocol. Okay, when I consider UDP, it was a message oriented protocol, and that was preserving message boundaries. Okay, when I consider UDP, we consider that one as message oriented protocol, and it preserves message boundaries. Like each message, if I consider, you are going to consider what are the boundaries we have for that one. And basically UDP we consider like it is not reliable, so we cannot have some kind of error control in that one. Even if your packet is lost, duplicated or received out of order, UDP doesn't care about that one. Okay, so UDP is message oriented protocol. It preserves message boundaries, and also if any packet is there which is out of order or lost or duplicated, UDP doesn't care about that one. That is about UDP in simple we can say. When I consider TCP, it is byte oriented, and it doesn't talk about message boundaries. So it just keeps on sending a stream of bytes. Where your packet is starting, where your packet is ending, it doesn't bother. But it just bothers about whether I am sending each and every byte as it is or not. Whether they are arranged in proper order or not. If there is any loss, it is going to retransmit that particular thing. So when I consider some real-time applications or multimedia applications, I cannot just go with UDP, because even if some packet is lost, it doesn't care about that one. But I cannot go with TCP because it does retransmission of these things. Okay, I need proper arrangement, but I don't need retransmission. Okay, I hope you are trying to get the point. I need arrangement which can be provided by TCP, but TCP also provides retransmission, which I don't need. So we need some features which are there in TCP, we need some features which are there in UDP. Okay, and we are trying to combine these two things in SCTP. So basically SCTP combines the best features of UDP and TCP. So by combining best features of both of these things, I can say like SCTP is a reliable message oriented protocol which preserves the boundaries. At the same time, if there is loss or duplicated data, it doesn't bother about that. But if there is out of ordered packets, it is going to consider, like it is going to reorder those things. Sorry, I said lost and duplicate data, it is not going to take care, right? But SCTP does consider if there is some lost packet or if there is any duplicate packets. Okay, so that is just some overview of SCTP we have. And when I talk about SCTP services, they are kind of similar to TCP itself. Anyone remember what are the services we have in TCP? Yes, do you remember the services which we are providing in TCP? Okay, so the first service TCP provides is process to process communication. Okay, same way SCTP also provides process to process communication. Okay, and if you remember, during TCP we said it provides stream oriented service. Okay, similarly SCTP is also stream oriented service, but SCTP can provide multiple streams. TCP can provide only single stream, but SCTP can provide multiple streams. We have the concept of multi-homing in SCTP. That is, multiple IP addresses can be there if I consider a particular SCTP. And also TCP provides you full duplex communication. SCTP also provides full duplex communication. TCP provides reliable service. SCTP provides reliable service. TCP provides connection oriented service. SCTP also provides connection oriented service. Okay. So these are the things we have under TCP SCTP services. And when I consider SCTP features, we have TSN, transmission sequence number, and we have stream identifier and stream sequence number. These are the features we have in SCTP. Okay. We will also see what is the packet format we have and what is SCTP association, and we will also see flow control and error control with respect to SCTP. Okay. So first, like with respect to SCTP services, what is SCTP? It is message oriented, reliable protocol that combines the best features we have in UDP and TCP. Okay. These are the features, like this is SCTP in short. Like what are the applications SCTP can provide? Okay. So different protocols we have and different port numbers which SCTP utilizes, and the description. Like if I am using ISDN over internet protocol, I have to use protocol port number this one. If I am going with SS7 telephony signaling, like you studied in your TSSN, SS7 signaling system 7 we have, right? So for that one we will be using this one. So similarly SS7 telephone signaling, we also have another one 2905 media gateway control, IP telephony. Like if I am using SIP, session initiation protocol, this is the port address we will be using. If I am using H.323, these are the port addresses we will be using. So similar to how we had TCP some port numbers, even for SCTP also we have some well-known port numbers. Okay. Then, like if you remember, in the case of TCP, we said it is stream oriented service. Okay. But we had only one stream connecting from a particular process to another process. But SCTP, it can provide multiple streams. Like I have one sending process, I have one receiving process, I can have multiple streams here. Okay. So this is something like TCP had single road between source and destination. Okay. But when you consider SCTP, we have multiple lane roads. Okay. I can go in this path, I can go in this path, whatever the stream I have, I can go with this, go with that one. But you need to remember, whatever the present implementation of SCTP we have, in that one, we can use maximum of one stream simultaneously. Okay, maximum of one stream we can use simultaneously. Then you can have a question like, when I can have maximum of one stream simultaneously, why we are saying like multiple stream concept is supported by SCTP? The answer is, for example, if this particular stream had some problem in the middle, then I can shift it to this stream. Okay, so that is the difference. So it is kind of providing some redundant service. If there is problem with this stream, I have a backup, I can go with this particular stream. But simultaneously I cannot use 2 or 3 or 4 any number of streams. Whatever the number we have, that many we cannot go with. Okay, is it clear multiple stream concept?
Yes, sir.
Okay. An association in SCTP can involve multiple streams. Okay. So if you remember in TCP, we used to say connection. TCP establishes a connection from source to destination. Similarly, destination to source also we can establish a connection. If I have bidirectional communication, it becomes full duplex. Similarly, when I consider SCTP, okay, I need to establish an association. It is not called connection, but it is considered to be an association. And I need to have one association from source to destination, and I need to have another association from destination to source. If I need full duplex communication, I need two associations. Okay. Multi-homing concept. Okay. So we said like we are going to have multiple streams supported. Similarly, we are going to have multi-homing concept. So the same device can have several IP addresses depending on what is the link to which they are connected. Here also, for example, there is some problem with this particular path. I can go with another IP address in another alternative path. Okay. So this is also redundant, which is available, so that in case we have any problem with one IP address, I can go with another IP address. Okay. SCTP association allows multiple IP addresses for each end. Okay, but simultaneously I cannot use two IP addresses. That means if I have a packet of 100 bytes, I cannot say 50 bytes I will be sending through this one, 50 bytes I will be sending through this one. Okay, but if there is any problem with this one, I will be going with the next one. Okay. In SCTP, a data chunk is numbered using a transmission sequence number. So in TCP, we were saying it as segments. Okay, segments, and each segment we used to refer with some bytes. Okay, so bytes is the one which we used to consider in TCP. But when I go to SCTP, we are not calling segments, but we are calling with another name, chunks. Okay, it can be data chunk, it can be control chunk. Okay, there we have sequence number. Okay, if you remember TCP, we had sequence number, but here we are considering transmission sequence number. Okay, to distinguish between different streams, like we said, like multiple streams are there, right? Okay. To distinguish between this stream and this stream, we are going to give some stream identifier. Okay, stream identifier we are going to consider in this case. Okay. To distinguish between different data chunks belonging to the same stream, SCTP uses stream sequence number. Okay, so we have three things: transmission sequence number. Okay, to give some kind of numbering to data chunks. Okay, and we have stream sequence number. Within a particular stream, we are going to give this numbering. Okay, transmission sequence number is going to be unique among all the streams. Stream sequence number, it will be unique within a particular stream. To identify this stream, we are using stream identifiers. Okay, then we had byte number, acknowledgement number, sequence number in TCP. These are the features of TCP. But when I go with SCTP, the features are transmission sequence number, stream sequence number, stream identifier. Okay. TCP has segments, SCTP has packets, or we call it as chunks. Okay. This is the comparison we have with the TCP and SCTP. When I consider TCP, we had all these things, but when I go with SCTP, we have source port address, destination port address, same as what we had in TCP. Then we have some verification tag. Okay, so this verification tag is useful in identifying a particular packet uniquely, and also if there is any duplicate, it will be identifying. Okay, and we do not have acknowledgement all these things, but anyway, checksum we have control chunks and we have data chunks. So this is mandatory header. Like how many bytes we have here? 4 bytes, 4 bytes, 4 bytes. 12 bytes of mandatory header we have. Here we had header length, but there we do not require header length because we don't have any options field in SCTP. So I don't need any header length. Even control flags, if you need anything, that will be part of this control chunks. So we are not specifically saying about that one. This window size is also part of control chunks. So we are not considering that. We do not have any push flag here. So we do not have any urgent pointer. Okay. Acknowledgement number, it will be there again in that control check. Okay. So that is the modification we have. Like when I consider TCP segment and SCTP packet. Okay. So HL, header length I don't need. Control flags, they are part of control checks. Window size, urgent pointer, all these things are part of control checks. So we are separating control information from data. Okay, that's what we are doing in SCTP. In SCTP, control information and data information are carried in separate chunks. Okay, they are not combined. You see here, like when I consider multiple packets, how we are trying to send them. Okay, so this is the first packet. Okay, I have some mandatory header, 12 bytes of header. Then I have some control information. Then with respect to data, the transmission sequence number is 101. Stream identifier is 0 because I am setting this one in stream 0. Okay, and this is the stream sequence number. So with respect to this stream, this is the first packet. So stream sequence number will be 0. Then I have transmission sequence number 1 or 2. Again I am sending in the same stream and the stream sequence number is 1. Okay, so I will have that one here. Then the next one I will have here. That is the first packet. Second packet, what we are doing? We are sending second packet first thing in stream 0 itself. You can see here stream 0, SSN number is 3. So with respect to stream 0, the number of that particular thing is 3. Okay. And in the second packet, the second byte or second thing, whatever I have, second chunk, data chunk, we are trying to send in stream 1. Okay. In this stream 1, we are sending. So with respect to original data, transmission sequence number is 105, but with respect to this stream 1, the sequence number is 0 because in this stream, this is the first one we are sending. Okay. Similarly, stream sequence number 1. Okay. Similarly, the third packet also I am sending 1 in stream 1. Then the rest of the things I am sending in stream 2. Okay. Is it clear that sequence, transmission sequence number, stream identifier and stream sequence number?
Yes, sir.
Okay. So data chains are identified by 3 items like TSN, SI and SSN. TSN is a cumulative numbering, identifier and association. Like with respect to original connection, what is the sequence number? Okay, that is given by TSN. Stream identifier identifies a particular stream. Within that stream, where is your position is given by stream sequence number. In SCTP, acknowledgement numbers are used same as how we are doing in TCP, but they are used to acknowledge only data checks. Control checks are acknowledged by other control checks. Okay, if I have some control check, something like init message, okay, or we have some cookie message. Okay, so these things are acknowledged by init echo and cookie echo. Okay, we do not have separate acknowledgement for that one. Okay, we are going to have separate control check for those things. Okay, so this is the packet format we have. So we described the general header, right? You are going to have general header. Then I am going to have chunk 1, chunk 2, chunk 3 and so on, chunk n. Okay, so I will have control chunk. Similarly, I am going to have some data chunk here. In SCTP, a packet control chunks come before data chunks. Okay. So this is the general header, whatever we considered earlier: source port address, destination port address, verification tag, and checksum. So in TCP we had 16-bit checksum, but in SCTP we are considering 32-bit checksum. Verification tag to uniquely identify a particular association. Okay. Security association, we are giving this verification tag. Okay, we said like you can have an association from source to destination, right? So we are going to give some numbering to that. that we call it as security association number, which we call it as verification tag. That is unique for each and every association. Okay. So we have different chains here and the corresponding types. Okay. So if it is data, you are going to specify like 0 init. It is used for setting up an association. To give acknowledgement to that, we are using init add. If you want to provide an acknowledgement, selective acknowledgement, we call it as SAT. Heartbeat, like whether your peers, your neighbors are available or not, that will be tested by using heartbeat message. Heartbeat acknowledgement, if someone is sending heartbeat message, you need to respond with heartbeat acknowledgement. If you want to close the connection, you will be using abort. If you want to terminate an association, we will be using shutdown message. And for shutdown message, you will be replying with shutdown act. We had FIN, fin message in TCP. Okay, fin plus act we had in TCP. So to replace those things, we had shutdown and shutdown act. We had SYN message instead of init, and SYN plus act we had, but here we have init and init plus act. If I have any error, we are using this one. Cookie echo and cookie acknowledgement. These are useful because in TCP we had some issue with respect to distributed denial of service attack, DOS attacks we call it as. To overcome that one, SCTP uses the concept of cookie echo and cookie act. Whenever you establish a connection, even you are going to exchange this cookie message. So whenever the other person gets this cookie message, then only they are going to reserve some resources in the server side for a particular connection. Okay. Shutdown complete, like you have shutdown act, and the other person has to respond the third type of message, that is shutdown complete, and forward TSN for adjusting cumulative TSN number. So these are different types of chunks we have in SCTP. A connection in SCTP is called an association, like we discussed earlier. No other chunk is allowed in a packet carrying init or init acknowledgement. Okay. So in TCP also, if you are sending SYN message or SYN plus act, we consider we cannot consider any other message along with this one. Similarly, here also, if I consider SCTP, init and init acknowledgement chunks cannot carry any other chunk. Okay, they have to be sent alone. Cookie echo or cookie act can carry data chunks. Okay. So init act cannot carry any other chunks, but cookie echo and cookie act they can carry data chunks. So this is four-way handshake where we are going to establish a connection. Whatever the three-way handshake mechanism we had in TCP, that is not suitable in SCTP. Okay, so we are going with four-way handshake. Okay, so there if you remember, we had SYN synchronization message to initialize the connection, but here we have init message which is used for initializing the connection. Okay, and there we had SYN plus act. Here we are having init acknowledgement. Okay, along with init acknowledgement, you are going to send cookie. Okay, and for that cookie you have to respond with cookie echo, then only you are going to get cookie acknowledgement and the connection will be established. Okay, so basically in TCP what used to happen is you will send SYN message. Okay, as soon as you send SYN messages, some resources will be allocated for this particular connection, and you will be sending SYN plus acknowledgement. After that, what should happen? You need to send acknowledgement. Okay, and you need to continue data transfer phase. But the attackers, what they used to do is they will just send SYN message. Computer will allocate some resources, or the TCP allocate some resources. It will respond with SYN plus act, but the attackers will not reply to that one. So what is happening? If I am sending 100 such SYN messages, 100 times resources will be allocated for me, but I won't be responding. So the genuine user who wants to utilize this particular information or the resources, they will be deprived of this particular resources, or they won't be getting any chance to use that services. That is called as denial of service attack. Okay, so to overcome that one, SCTP is utilizing this concept. So SCTP doesn't allocate resources immediately as soon as you receive init message, but you are going to send cookie, okay, and again you will have to respond with cookie echo, and this will compare whether the cookie I have sent is same as whatever I got. If I have confirmation, then I will be sending cookie acknowledgement and I will reserve some resources. Okay, so that is how DOS is handled by SCTP. Okay, is it clear? Four-way handshake, how we are establishing a association in SCTP?
Yes, sir.
Okay. So in SCTP, only data chains consume transmission sequence numbers. For control chains, we do not have any transmission sequence number. Data chains are the only chains that are acknowledged. As considered earlier, if I have to acknowledge control chains, we have another type of control chains. Like here you can see I am sending some data. So TSN number, like as we considered with respect to TCP, if I am sending any data within one single packet, we used to consider one sequence number, that is the starting byte. But in SCTP, we have multiple chunks of data and each chunk is represented with some transmission sequence number. Okay, I have sent the data. I'm still I have data. I am sending the data. After that, I am getting cumulative acknowledgement. Okay, so we are expecting 7108. Like I have received till 7108, and I am saying selective acknowledgement I am sending. So what is the difference you observe here? I have sent till 7108. It is saying cumulative TSN is 7108. Like that, it is sending some acknowledgement. Then I have 121, that sequence number coming, 122 it is coming, and you are saying cumulative TSN is 122. Okay, this is the selective acknowledgement we are providing. So what does it mean? What is the difference I have when I compare TCP and SCTP with respect to this one, acknowledgement? Yes.
Sir, in TCP, the acknowledgement will be after each and every step, sir, like from server to client and client to server. But here it is not like that.
Can you repeat?
Sir, in TCP, the acknowledgement will be sent from client to server and server to client after each step, like after sending each data. But here it is not
Okay.
like that.
Any other answers? Any other answer? Like even in TCP also, you can send acknowledgement for 2 or 3 packets at a time. Okay, we don't have to send for individual packet. Yes, any other answer? No, nobody has any difference, found any difference here? Yes. So, for example, if this is TCP, what is the number I will keep in acknowledgement? Whether I will keep 7108?
Seven one zero nine, sir.
Rule number 11, your video is on. Like, what is the difference? There you are saying 7109. What does it mean?
The next byte, sir.
So in TCP, we are talking about what is the next expected byte, right? What is the next expected sequence number? That information we are giving in acknowledgement. But when I consider SCTP, what is the sequence number or what is the TSN number till which I have received successfully in order? Is it clear?
Yes, sir.
Yeah. In TCP, we are saying if this is the case, I will be giving number 7109 in TCP. But in SCTP, I am saying till 7108 without any issues, I am getting acknowledgement. I have received data. Like that, we are saying. Okay. So the acknowledgement in SCTP defines the cumulative TSN, the TSN of the last data chunk received in order. But SCTP, it says what is the next expected sequence number. We are saying here what is the data which I have received successfully. That is a difference. Okay. So an association, if you want to terminate, we will be using shutdown message. The other person will be responding with shutdown act, and you will be sending back shutdown complete. If you remember TCP, we were sending fin message. For that, fin plus act will be coming, and again this person will be responding with act. Okay, so that is the difference we have. Their finished message we have, here we are having shutdown message. Their fin plus act we have, here we have shutdown acknowledgement. And there again we used to send acknowledgement to shutdown act, but an acknowledgement to shutdown act is shutdown complete message. Okay, that is the difference we have. Association termination we are going to do like this in SCTP. Okay. Now we shall talk about flow control, how we are going to do. Okay. So you see here same like whatever the window size etc. we used to do, the same way we are going to consider here also. This is with respect to receiver side. Okay, at the receiver I have this buffer, okay, or queue I can say. 22 I have received, 23, 24, 25, 26 till 26 I have received. This is the extra space I have where I can receive more data. Okay, and whatever the data I have in queue, that is the data which I am yet to process. Like I have not completed processing that. Okay, here we are considering, let us consider each number, like each thing has 100 bytes. Okay, 100 bytes we are considering. Okay, so till 26 I have received properly. So you see here, you are going to have the data here, like 26 is the cumulative TSN number. Okay, this is what like they have to keep on track of these things. Cumulative TSN is 26, but till what I have acknowledged, till packet number 20 I have provided acknowledgement. That is what we get from last acknowledgement. Okay, what was the last acknowledgement I have provided? 20. Okay, till what I have? Till 26 I have here. What about 21? 21 is not there in the queue. Okay, but it was processed by that particular SCTP process. Okay, but I have not given acknowledgement for that one. Okay, along with this, how much space I have? I have 1000 bytes of data. That means if I consider 100 bytes, each chunk is there, I can have 10 more chunks which can arrange here. Okay, so at the receiver side, you are keeping track of these things. What is the cumulative TSN? That is how many packets I have received so far, and what is the window size I have available, and what is the last acknowledgement I have provided. Okay, so for example, let us consider I have received two more chunks, 27 and 28. In that case, what will be the cumulative TSN? Yes?
28.
28, because till 28 I have received. I will be storing here 27 and 28. Okay, and I will be updating this value as 28. Okay, and what about window size? We said each packet has 100 bytes. Each chunks carry 100 bytes. Okay, whether window size will increase or decrease?
Decrease.
Yes? Can you repeat?
Increase, sir.
You are telling with some doubt. Let me clarify. Window size is the amount of space available or free space available in queue. Now tell me whether window size will increase or decrease.
Decrease.
Decrease. And what will be the updated value now?
800.
800. So 1000 minus how many I got? 200. So I am going to update this particular value with 800. What about last acknowledgement? Yes? There won't be any change in last acknowledgement because I have not provided any acknowledgement for source. But if I had provided acknowledgement, okay, let us say I have provided acknowledgement number 24, okay, till 24, or let us say till 26 I have given acknowledgement. Okay, earlier I had given acknowledgement till 20, now I am giving till 26. How these things will change in this case? What about cumulative TSN? Is there any change or update?
No, sir.
No, because I did not receive anything. So cumulative TSN will be 28. What about the window size?
Same 1000.
1000. How? When you send acknowledgement till 26, I will remove all these things. Okay. So what are the packets I have removed? I have
5
removed
packets.
like 21, 22, 23, 24, 25, 26. Okay, total 6 chunks I have removed. So I need to add 600 to this one. Whatever the window size I have, for how many chunks I am providing the acknowledgement, that many bytes I am going to add. Okay, whatever the size I had, okay, in this case I am considering 100, so you are going to add 600. Okay, and what will be the last acknowledgement value?
26.
26, because we have updated till 26. Okay, so in this thing I have considered two scenarios. One is when I receive some data. When I receive some data, what happens to these parameters? And when I send acknowledgement, what happens to these parameters? So in exam there can be a question, how flow control is handled by SCTP at receiver side and sender side. This is at the receiver side. Okay, is it clear?
Sir, I have a doubt, sir.
Yes.
Sir, if the acknowledgement is sent for 26, sir, then the window size will be 1000 plus 500, no, because 22 to 26, 5, no, sir.
See, if you remember, after this particular case, I had received some data, then I have updated this as 28, 800 and 20, right?
Yes, sir.
Yeah, after that I said like, I have provided update till 20. After that, how many packets I have? 21, 22, 23, 24, 25, 26. That means I am providing acknowledgement for 6 packets. What is the corresponding size of all these 6?
600.
So I am adding 600 to this one and updating this one with 26. There is no change with this one. Okay?
Okay, sir. Yes, sir.
Yeah. At the sender side, how it will be? Okay. Sender side also, you are going to have same sender queue as it is. Okay. And these are outstanding checks. When I say outstanding checks, it means I have sent these things. Okay. And okay, I have sent all these things, but I have not received any, what I can say, acknowledgement for that. Okay, here some mistake is there with figure. This is not 29, all these things. Like numbers are 29, 28, 27, 26. Okay. So outstanding checks are like, I have sent some of the packets, but I have not received any acknowledgement for them. Okay. In that case, I am going to keep those things in this one. Okay. And these are the ones which are yet to be transmitted. Okay. So current TSN, what does it say is, whatever the segment or whatever the data packet which I have to send now is 37. Okay. Let me erase all these things. So the packet which I have to send is 37, but I have sent all these things already. Okay. So this current TSN points to what is the packet which you are yet to send. Okay. And this receiver window size is the window size which we got information from the other side. Like without waiting for acknowledgement, I can send 2000 bytes. Okay. And this 700 says how many packets are in transit. Transit means the packets which are not acknowledged. Okay. So just a correction. I said like I can send 2000 bytes without waiting for acknowledgement, right? It is not 2000, but I need to consider receiver window size minus in transit, because these 700 are the packets which are there at the receiver, but it has not acknowledged or it has not provided any acknowledgement. So the receiver window size is 2000. Already in that one I have filled with 700. So how much I can send? 1300. So whenever you want to send any data, sender will look here. Okay, I have this value 1300. If I am sending this 37, whether the size of this one is less than this 1300 or not. If it is less, it will send the data. And how this current TSN will be updated? It will be updated with 28. And what is the receiver window size? Receiver window size will be same, but in transit I am going to have 800. Okay. Whenever you send any packet at sender side, it is going to update like this. I have sent till 38. Okay. Sorry, 37 I have sent. Next I need to send 38. Okay. And receiver window size is this much. In transit I have 800. Okay. Again I have to send 38 one. So I will send this one. So outstanding packets are till this point. So I will keep 39, 2000, and here I will keep 900. Okay, like that we will be updated. Okay, is it clear?
Yes, sir. Sir, so here the receiver window size will not change.
Yeah, receiver window size is not changed. It will be changed only when this in transit thing is cleared and you get some updated receiver window size from the other side.
Okay, sir.
Okay. Okay. Then, for example, I have received some acknowledgement. Okay. In the acknowledgement, it says receiver window size is 1000 and cumulative, like CUM TSN. That is what we are saying, right? Cumulative TSN is 39. Okay. Sorry. It has received till 38, right? So it will say this one is 38. In that case, this will be updated like next I have to send 39. Receiver is saying it has 1000. Okay. Is there anything which is pending? I have sent till 38. I got acknowledgement till 38. So this one will be 38. Sorry, in transit it will be 0. Is it clear?
No, sir. In transit concept I didn't understand.
Okay, it will be more clear if I consider this an example. Okay, let us see. So this is the case, like this is the first sequence number I have. Receiver advertised earlier like 2000 is the receiver window size it has. Okay. In transit, I did not send anything so far. So in transit, I will consider 0. Okay. And these are the packets which I am yet to send. Okay. I am sending the first one. Okay. First one I have sent. Before receiving this one, this was the position at the receiver side. Cumulative TSN, I did not receive anything, so it will be no value. Last acknowledgement, I didn't provide any acknowledgement, but I have 2000 bytes of buffer space. So as soon as I send this one, okay, it is updating. How it is updating? I have received the first one, so I will say cumulative TSN is 1, and I am considering each has 1000 bytes. You can see here. Okay, so I will remove 1000 from here. Okay, window size will be 1000. I did not provide any acknowledgement. Okay, so it will be there in my buffer. At the sender side, what happens after sending this? This is like whatever the one we have here. Okay, that one is outstanding packet. Okay, so I will say I have 1000 bytes of in transit data. What was the updated value? What was the receiver window size? It was set 2000. What is the current TSN? Like if I am sending one more packet, I need to be sending second one. Okay. Now you see I am sending the second one. TSN2 again it is 1000 bytes. Okay. While sending, I will check the receiver window size minus in transit. I have the value 1000. So I can send 1000 bytes of data. If I have 1100 bytes, I won't be able to send that particular information. After sending, I am updating. Like 1 and 2, they are outstanding packets. So in transit, I have 2000 bytes. Receiver window size is 2000. Current TSN is 3. So without getting any acknowledgement, I won't be able to send 3, 4 like this. Okay. So after receiving the second one, you see here, current cumulative TSN is 2, current TSN is at sender side, cumulative TSN is at receiver side. So I have 2, window size is 0 because I have 2 unprocessed data here. Okay, I don't have any memory to receive any data. Okay, I am just sending selective acknowledgement where I am saying acknowledgement is 2, receiver window is 0. Okay, I am not processing, so I am not updating the receiver window size here. Okay, so that particular thing will be received by the sender. So I got acknowledgement. Okay, so which says 2000 bytes have been received. So in transit I will update with 0, and I am also receiving that receiver window size is 0. So I will update with 0. And what is the current TSN? It is 3. And whatever the outstanding packets I had, that I am eliminating from this queue. Okay. Later, again I am getting an acknowledgement with ACK2 and receiver window size 2000. In that case, I will be exchanging this receiver window size with 2000. Okay. Is it clear now?
Yes, sir.
Yeah. So similarly, you can also see, like after sending this acknowledgement, last acknowledgement, like after this, when this one actually reads 1 and 2, you will be updating like I have provided acknowledgement till 2. Now I have updated window size. I have cumulative TSN 2. So it will be sending this acknowledgement. Okay. So that is how the process will be going on. Then with respect to error control, how at the receiver side we will be handling error. So I have some gaps, like I have received 21, 22, 23 properly. Okay. The cumulative TSN is 23. Cumulative TSN, it is like the number of TSN till which we have received without any problem. Okay. Basically, I have received till 34, but I had 2 missing packets here, 2 missing packets here. 24, 25 I am missing, and 29 and 30 I am missing. Okay. So I am not writing 34 here, but I am saying 23. And what is the window size? I have 1000 bytes of space available to receive some more data. And I have provided earlier till 20 that I have received data. Okay. So whenever you are sending acknowledgement, basically selective acknowledgement we call it as, there is separate format for this. Okay. Anyway, that is not part of the syllabus, but that particular format includes this information. It will have these things: cumulative DSN, what is the acknowledgement, what is the window size. Then it will also say what are the out of order packets. So in out of order queue, you are going to say like what is the starting byte where I have received this out of order packet. That is 26 is the starting one. That is the starting out of order packet till where I have received properly again till 28. So I will say 26, 28. So I have received 26, 27, 28. But I did not receive something before. Similarly, I received 31, 32, 33, 34. Okay. So 31 is the starting one, 34 is the starting one. In bed, like before that, I did not receive something. Okay. In the out of order queue, you are going to keep that information. If I receive any duplicates, for example, I received 22nd duplicate, 31 duplicate, I am going to keep track of those things also. Okay. So this is how you are going to keep at the receiver side. Okay. Now we shall check at the sender side. Okay. Sender side, you see here current TSN, like I have sent till 36. Okay. Current TSN is 37 because that is the one which I have to send. Receiver, it advertised earlier like 2000 is the window size, and I have 1400 bytes of in transit data. Okay, 1400 bytes for which I need to get acknowledgement. Along with this one, you are going to have something called as retransmission queue. Okay, here we will be adding a particular packet whenever the timer expires, or we get 3. It's not 3. Basically, it is 4 selective acknowledgements. Okay, so whenever I send 21, I'll be starting a timer. When timer expires, I'll have to do retransmission. So I'll be keeping that particular 21 here. I'll be removing from outstanding checks. I'll keep in retransmission thing. Okay, and I have received like for 22 also timer expired, so I'll be adding this. So whenever you are sending next data, these two like 21 and 22 will get first chance. Okay, they will be given priority to send first. Okay, we won't give priority to 37, 38, 39, but we will be giving priority to 21, 22 to send the data. Okay, and if I get an acknowledgement, okay, for 21 and 22, we will be eliminating those things from retransmission queue. Okay, and also like we will be eliminating from these things. Okay, so that is how error is handled. Like at the sender side, receiver side, you are going to keep track of what are the packets which we received out of order, what are the duplicate packets. Whenever you are sending selective acknowledgement, you are going to provide these details. At the sender side, you are going to keep retransmission queue. If retransmission happens, or if you receive 4 selective acknowledgements for the same number, then you will add those things here, and you are going to do like you are going to give highest priority to these things before any other packet. Okay, is it clear?
Yes, sir.
Yeah. So in SCTP, if they ask write about flow control of SCTP, you need to write these things. Okay. This one, how you are doing flow control at receiver side. Okay. Sorry. And how you are doing at sender side, and a scenario. Okay. And if they ask about error control, you need to talk about at receiver side how it is done, at sender side how it is done. And about congestion, same congestion control algorithms, how we are handling at TCP, we are handling in this SCTP also. Okay.
Sir,
So that
should
is
we?
the end of this SCTP. So we have done with UDP, TCP, SCTP, and I have recorded multimedia that is available in